Welcome to this webinar. Today we're going to be talking about getting the most out of Java on Azure. My name is Brian Benz. I'm a Senior Cloud Developer Advocate at Microsoft. My job is to work with the Java community to make sure that the offerings that we have for Azure fit the needs of the Java community, and also just make sure everyone's aware of what we actually have out there. I'm going to be showing a lot of that today. There's actually more to come as well. So for the agenda today, I'm going to cover at the beginning some of the common app issues that you're going to have when it comes to the cloud. And these are actually just app issues that you would have on-prem probably as well, but they actually get magnified in the cloud just because of all the different moving parts you have when you're actually out there, and because you don't have 100% control of the infrastructure that you're running on. As you have a lot of control, but you don't have as much control as you have on-prem. Then I'm going to talk about architecture issues, and once again, there's a lot of architecture issues, a lot of facilities that you don't have in a regular environment that you do have on the cloud that you can take advantage of to actually build your Java applications. And today I'm actually going to focus on infrastructure. There's a lot to cover here in terms of performance, and in the future I'll do more of a session on containers. But today I'm going to talk about virtual machines, infrastructure as a service, and show you how we build these things called scale sets, which allows you to flexibly grow your scale on an application and manage things so that you don't run out of steam, or and also you control costs when you don't need so much infrastructure. Moving on from that, I'm going to talk a little bit about architecture in terms of containers, service fabric, and web apps. These are things we have. We have in Azure, we have Azure Container Services, which is a container managed orchestration service with Kubernetes. Docker Swarm, DCOS, all the popular orchestration services that you're probably familiar with. We also have something called Service Fabric, which is a managed service that allows you to maintain your applications. It's really ideally built for microservices and containers environments, so it goes beyond Kubernetes and the standard orchestration to actually build an infrastructure with you on the back end for your data stores and also applications. And then we have web apps, which is sort of a sandboxed application environment. For example, we have a Tomcat web app, where all you have to do is fire up a Tomcat web app and drop your WAR file in, and you can be up and running in a few minutes with your application on Azure. We have Linux and Windows web apps. The Linux web apps are built on containers. We'll talk about all this in a little bit. So let's move on, and I'll show you a little bit about the application that I've built to demonstrate some of these things. For this particular session, I wanted to use something that was out there that existed already, everyone could get access to. It's all free and open source and on GitHub. So I used Spring Music. It's a Cloud Foundry demo, and it's a pretty cool one. It's out on GitHub, cloudfoundry-sample/spring-music. This is what it does, basically. It's just a simple app. It runs, in this case, it's running on a virtual machine on Azure. You can sort by title, by artist, by year. One of the things I really like about this app is the flexibility that you have. Let me show you what I mean by that. So I'm going into Visual Studio Code here, but I'm showing you the Java inside there. So the application itself, the Spring application, is pretty simple. As you can see here, this is the main application Java code. It's not much. Spring handles most of it, Spring Boot. But down here, this is what I really like about this app. You can see you have multiple options for backend. So this is great for testing performance and playing around with different options on the cloud. And in this case, you can use MongoDB, Postgres, MySQL, Redis, Oracle, or SQL Server. By just changing the command line options when you're actually running the app, you can do that. And what I did is I set up an application properties in the application itself, and you can in this case, what I've got is I've got an example here. I took the keys out, but this example would basically work for MySQL and for MongoDB if you put the correct values in here from your actual cloud services that you run. And I'll talk about those cloud services in a minute. So that's the app, and I'll get back to that in a little bit, but just for now, let's go over some an overview of some of the app issues that you might run into when you're moving things to the cloud. So the first thing I'm going to cover is Java app issues, then we'll talk about architecture. These are generally covered with code and app settings. The first big one is JVM availability. So, you know, making sure that the Java executable that's running the application is actually accessible to the application when it comes to large amounts of data large amounts of activity and large amounts of data. Basically, just make sure that it's located close to the application and that you're monitoring the JVM, especially thread pools. So thread pools are pretty important. You have to make sure that you're monitoring thread pools to make sure that you have enough, and if you don't have enough, there's a scalability issue. Really, you just have to basically scale out using virtual machines or containers and start spreading your app a little further so that the CPU and the threads that you have per CPU will be managed okay. And I'm going to show you different options for doing that in a bit. There's also Java heap and garbage collection. So garbage collection, obviously you have to maintain and monitor your garbage collection, make sure that you're not running out of space for that. There's different ways that you can enable garbage collection management. It's pretty basic stuff, but there's a lot of documentation out there for that. Session settings. Sometimes people will just basically have too much data in their session settings, and it slows things down because the CPU has to access those that session data every time it makes a connection. The way to handle that is to offload session management to a key value pair manager like Redis, or have some other means of decoupling your sessions from your application and from the CPU that the application is running on. Logging issues. This is a really common one that people overlook. Logging, if you just have too much data in your logs, it takes too long to write and it slows things down. And on top of that, third-party library issues. So you have to make sure that the libraries you're using are from a trusted source, and you've got application that you've actually tested the application with these sources at a serious load, so that you have confidence that things aren't being slowed down by that third-party library. In fact, that's usually where I start if I have performance issues and it looks like I've got enough hardware thrown at the problem. I'll probably start with third-party libraries to see if there's an update, and then after that move into logging to see if there's just too much data in the logs. And of course you manage that by archiving mostly, or deleting, aggregating. There's different ways to do that. And then I'll move into thread pools, checking thread pools and checking my JVM availability, because those are the easiest things to do. Garbage collection and session settings are generally the most difficult, I find. So that's just a little bit about app issues. Those are the ones that you need to watch out for the most. Today we're really going to focus a lot on architecture issues, and these are solved by scaling and using tools that are available to you in the cloud, designed to help you with architecture. The first one really is slow VM. So you're basically your VM can't handle the load. The next one is load request, making sure that the actual network, that there's not a lot of latency on the actual network. The CPU might be perfectly fine to handle it, but you still have issues, and that would be a network, traffic management, things like that. And then database system latency, making sure that the database system is actually up to the task in terms of the service level and also scaling. And what I'm going to do later, I'm going to show you, I've created this thing called a scale set, virtual machine scale set, to handle the back end on MongoDB for the application I showed you. And then database connection overload. So just as important as thread pools is connection pools. So you know, 50. I think the main rule of thumb is 50 per CPU in general for database connections. And I'm talking application to database, not end user to database. So application to database, you have to make sure that you've got enough. The backend system is basically handling the connection pools. And then there's you know, other backend system latency if you're using a queue manager. If you have storage related to your applications as well, and most do. Then you know, is that an issue? Also caching. You know, caching can actually, if it's inadequate, slow things down. So even though it's designed to speed things up. Okay, so that's just an overview of the apps and architecture issues that I wanted to share with you. So Azure servers. So we talked about CPU. You know, we have basic things. Actually, this would be a good time to go into the portal. So let me go in there quick. So I'm going to show you in general what you can do with applications. This is the Azure portal in case you've never seen it. Basically, if I say new, okay, and then compute, there's a lot of different options I can have here for servers. In the case here, let's pick an Ubuntu server. Ubuntu server. If I want to create this, I'll just pick something for now that's general. I can set up SSD, HDD, and then I can use a password for this. I'm not actually going to create this, so I'm going to have to do that. But I want to get to the part. Let me just there are minimum requirements for the password. And there we go. So what I want to do is get you to the part where I show the different, I don't know. Okay. I want to get to the part where I can show you the different machine sizes. There we go. So there are, when you're creating the VMs, there are a large variety of machine sizes that you can use. Typical Ubuntu here, and there are tons. So when I click on View All, there are a number of CPU options I can have, and as you can see, a variety of prices as well for month, and you can really get up there. And there's different levels as well, standard, et cetera, et cetera. So basically, throwing hardware at it is an option, and let me show you the different options we have. So typically, I mean, a couple of years ago, our Gen 2 was pretty big with the cores. Gen 3, 8-core, 128 gigs of memory, and 4 terabyte hard drive. And then we sort of evolved here. Let me get into the more interesting stuff, which is the Gen 5 with 512 gigs and 6 times 950 gigs flash memory built into the actual application core. So this is what I was talking about, JVM availability. This is awesome if that's the kind of horsepower you need. The GPU is even better. It's got 950 gigs SSD, and then if you want to get up into our beast mode, it's got 4 times 18 cores. It's got 4 gigs, or sorry, unbelievable amounts of RAM, and it's got, can everyone see this in the back, by the way? Sorry for the small print. And it's got a huge amount of SSD, and it's also got a 40 gigabit per second network card as well, which is pretty cool. So basically throwing hardware at it is an option these days. You can start here and you can scale up. So speaking of scaling up, so when you build these CPUs, you can actually scale up to different versions pretty easily through the portal that I just showed you, or through the Azure CLI, the command line interface, which I'll show you in a bit. So there's different options for throwing hardware at it, basically. Now, I wanted to show you a picture of this. This is our Dublin Microsoft campus, but it's also our data center. You can see on the right there, those little containers. There's a huge amount of processing power. We have, I believe, 43 of these around the world, and I've been told you can see them from space. So this actually does have something to do with performance. So let me tell you why. Because of regions. So there are regions. We have 43 regions around the world. And they're defined by bandwidth and latency envelopes. So regions are visible to you. In practice, actually, there are several data centers behind each one of those regions. So the reason why I showed you that picture is that's one of the data centers for the Ireland region, and there's going to be 2 others in other locations. So they have faults and flood zones, and also they're designed for scalability. So for example, we have a region envelope. So East region, West region, North and South are North and South are linked together virtually to be managed for high availability. You can actually set your things up in one region, have it backed up in the other region, or have access from that region as well. And when you write data, the data is actually going to be in a reasonable amount of time updated in both locations, even though these are physical locations very far from each other. So it's good to keep, it's very, very good to keep track of availability zones. The availability zones themselves are how we actually describe those regions. So each geography, as I mentioned, has, you know, a few availability zones. Inside those availability zones are multiple data centers. So reliability and performance, it's important to keep into consideration with these. So subscription 1, you might have 3 availability zones you're using, and then subscription 2 will have 3 availability zones as well, but not the same ones. And the reason for that is you need a minimum of 3, by the way, to have full availability, and as long as you keep in mind the regions as well, that will improve performance as well, because we have those regional envelopes. So virtual IP addresses, this is another way. So how do we actually communicate and connect through those availability zones? You can use a virtual IP address, and you can have VNets, and basically the VMs themselves are organized by the virtual IP address. Everything's hidden behind the scenes in availability set for that. And I'm going to show you a little bit about availability sets in a minute. And the next thing we have in those virtual IPs, we have customer addresses and then platform addresses. The platform addresses are tied to physical devices, and that's what you would use behind the scenes to manage things. And this is probably a good time for me to go in and show you. Let's close this down. Okay, back to home. So inside here, I've got an availability set, actually, that I've set up. And in this case, as you can see here, what I did is I wanted to take a regular MongoDB database, but I wanted to have it set up in multiple, it's basically accessible through one IP addresses, which is in My Spring Music 0. And that connects to My Spring Music 1, 2, and 3 on the back end. Each one of those is running MongoDB. So that application I showed you at the beginning is actually hitting My Spring Music 0. And that is managing availability and basically choosing which one of those other VMs we want to access. Here's a little diagram of my Spring Music 0, and each resource here is what makes up that IP address. So there's a OS disk, there's a data disk, in this case 50 gigs, 30 gigs of OS disk to manage any operating system JVM issues. Then we have a data disk of 50 gigs in each one of those VMs to manage any fault tolerance that we need and also performance that we need. So each one of those databases can be accessed through through this particular virtual machine, my Spring Music 0. If you look at the other virtual machines, you'll see they don't actually have a public IP address because they're all managed by the availability set. So, Azure Functions. So these are some of the things I wanted to talk to you about that we have that you can use to manage your application as well. And these are in order of performance. In fact, the most performant ones are at the bottom. So the first thing I want to show you is Azure Functions. It's serverless. It's our serverless offering. Basically, it's a bunch of functions that you can access to work with our services like SQL, MySQL, MongoDB, et cetera, et cetera. And then we have web apps, and web apps are managed services, basically sandbox. So we have a Tomcat web app, for example. So it's a Tomcat. You build it up, and you can actually deliver that. You can deliver a WAR file to the web app, and that's all you need to do. Fire up a web app, Tomcat, drop your WAR file in, and it'll start running. A little bit more complicated if you need a little more control over things, but actually performs a little better as well as Service Fabric. So Service Fabric is PaaS. It really works well with microservices because it's all container-based underneath the scenes. It's kind of a cool way to manage your microservice container-based applications and have a little more control than you do in web apps. Azure Container Service as well is our container orchestrator. We support Mesos, Kubernetes, Docker Swarm, and of course Docker containers. And you can manage those directly. You set up something called an Azure Container Registry, which is where you actually manage your applications and your containers that you want to put out on the cloud. Then you can deploy, for example, to a Kubernetes cluster from an Azure Container Registry. And I'll show you a little bit about this on the portal in a minute. And then we have virtual machines. So virtual machines themselves is what I'm going to focus on today, and in the future, we're going to have another session on containers where we'll talk a little bit more about Service Fabric and Azure Container Service as well. So VM scale sets. This is the one I want to focus on today. I showed you a little bit in the portal about the VM scale set that we have. They're auto-scalable, they're fast, they're customizable, so you can run Windows or Linux. In this case, I have Ubuntu running. It's actually running MongoDB through a Bitnami image, which I'll show you in a minute. You can have VM extensions. We have customized VM extensions to actually allow you to access Azure services. And the nice thing is you just focus on the instance count, and they are updatable and scalable. So the one I showed you has 3 VMs, basically with a front-end VM, but you can have more. So on Azure, you create resource groups. Every application has to have a resource group, and inside that application you have multiple resources, and that's a way of managing not only your actual instances but also performance, and you can have different resource groups for different locations, et cetera, et cetera. So inside that resource group you have multiple VMs, which is basically your scale set through a subnet. There's a scalable NIC that is associated with each one, storage, and extensions. So let's go back to that VM that I showed you earlier, Spring Music Mongo. So you can see here I have a storage account, I have a virtual machine, Spring Music 0, I focused on a little bit. And then Spring Music 0 NICs, so there's 1, 2, 3 VMs, there's also 1, 2, 3 NICs, and then there's a public IP address, and then the actual availability set is managed here. All these things, it looks like a lot to set up, but actually I used the Bitnami MongoDB for Microsoft Azure multi-tier solutions, which is a VM that we have, actually a VM scale set that's pre-made on Azure. And basically the idea here is that you have as many VMs in the scale set as you need. Instead of talking about it anymore, let me just show you. So when you go into new, and I'll search the marketplace, MongoDB. So to set this up, I actually just set this up last night. I was playing around with the Spring Music app a couple days ago, and I got it working locally, and then I wanted to publish it out. So what I did is I went here and I went into the marketplace, MongoDB with replication, and I just said create, and I use I can use their deployment name, your application database. As you can see here, the name of the application database you're going to use, and then application credentials. This is actually for MongoDB, so I can type in a password here. Make sure hey, I did it. So number of slave machines to create. I created 3, but you can create up to, let's see here, 32. So you can create 32 with this particular image. I'm not actually going to create this. I just want to show it to you. Arbiter nodes. So arbiter nodes are basically what you would use to solve any conflicts that you have. So the part of a replica set, they break ties, and if you have an even number of members, as we do here, you have to add an arbiter. So, and then I'm just doing this so I can show you the next step. All right, and then basically then you set up your password. You can use an SSH public key. This is for the actual VMs. So I think I screwed that one up. Yeah, I did. It's all live code, folks, so hang on. I typed this one wrong then, obviously. Okay. Hey, there we go. So then I can pick my VM size, and this is going to be for all 32 cores. So it's going to make VMs for 32 cores. I already showed you all the different view all. So I can just choose one of these. I'm going to choose this for now. Select, okay. And then basically it's going to validate, okay. Now one of the things, when I hit OK here, it's actually going to confirm and roll out this VM scale set. But the other thing I can do here is I can click on add the template, and this template is actually something we call Azure Resource Manager. So Azure Resource Manager, and I can save this template to a library, and this will actually be saved for later. So all that configuration work I did, I can actually use this later, and I can build it through the portal just like I did there. Or if I have to share it with a team in my company or something, I can do that as well. So I'll just close that and get back. So if I say OK here, it's actually going to buy this. It's going to confirm it, and I won't do that for now, but I'll show you the scale set that we already have. And that's basically what you do to set up a 32-core MongoDB scale set. Once that's done, then you have one like I have in my dashboard. I have Spring Music Mongo, and from there I can basically access this through Spring Music 0. So when it's all built, this is what it looks like when it's all built. There would obviously be more cores. You would have everything here, and then you just go into my Spring Music IP. You can get the IP address there, and once you've got that, you can access that. You put that into your properties. So there's a host, which would be the IP, the password, the username, and the port that you want to use. And by the way, these don't use standard MongoDB ports with the Bitnami image, so you do have to specify that. And once that's all plugged in, then you have an app that looks a lot like this and basically runs. This one's running on 3 cores, but it could be running on 32 as well. So it's an easy way to scale things, but that's basically in a nutshell what you do. There's a lot of work that is taken care of by the Azure portal. So that's essentially how you actually build up a scale set to actually handle the architecture for that. Now, application architecture, I didn't mention that. So that's the back-end database. The other thing we have is, in this case, I just went with a regular standard VM just because, with a pretty powerful VM actually. Let me see here, Spring Music. Spring Mongo Single, I called it. And this is what the actual application is running on. And the Spring Mongo Single is just a regular VM. It's got, I believe, 8 cores with a ton of CPU. I can upgrade that VM anytime I want. I can create an availability set if I want here to actually add. Oh, okay. So I have to recreate the virtual machine to actually move in and out of availability set. And actually, yes, I recall now, that was one of the things you have to do. So when you actually create the VM, you have an option there of moving into a availability set as well to bring that up to speed. And we'll talk a little bit about back-end options as well. So I showed you setting up a VM. You know, obviously the other thing you can do is use services that we already have on Azure for this. Instead of setting up a VM, you can use our Azure Container Service. We also have something called Azure Container Instances that allow you to fire up and shut down Azure containers really quickly for dev test. And then the Azure Container Registry actually holds all the information. So let's say you need a MongoDB image. You can get a MongoDB image from the Docker Hub. You can put it into your Azure Container Registry, and then you can deploy it using Kubernetes out to the Azure Container Service. And I'm going to cover that in a future webinar. I'll show how it can actually be done. So basically, this is just a little animation that just shows you what you can do with this. The other thing I want to show you a little bit is all the different services. So speaking of back-end services that you can use, so one way to scale this is, of course, scaling up your app and scaling up your back-end services on VMs, and you have complete control over everything. And the only thing is, you have to update everything. You have to update Mongo when it comes out with a new version. You have to update Ubuntu, et cetera, et cetera. We also have services you can use on the back end to access these things as well. So Cosmos DB, for example, is our multi-model database. Now let me just so Cosmos DB is a multi-model database that you can use. It actually manages SQL, so you can actually access it. It looks like MySQL. Depending on how you set it up, it can look like MongoDB, depending on how you set it up. And we also have multiple other options like table storage and things like that that are built into Cosmos DB. Let me go into the portal. So I actually created a Cosmos DB configuration here, and I've got a data set that I've created. And in order to change this application to point to Cosmos DB, the first thing I would do is just go in here. I'd create a new Cosmos DB. Let's see. Actually, let me go here. MongoDB. DB. So same thing as I did before, but this time, what happened there? Hold on. It's going directly to the MongoDB app. Hold on a second. New MongoDB. There we go. Database as a service for MongoDB. This is actually our Cosmos DB version, and it can look like MongoDB. So what you would do is you'd actually just set up the application properties here. In Spring Music, for example, you would set up the MongoDB host, password, username, and port. So that's what happens when you set up Cosmos DB through here. And basically, it's a simple application. Let me get back to the one I already created. And I can show you all the keys. I'm going to have to delete this one after I do this, but yeah, basically, if I click on connection string, it gives me all the information that I need to set up that host, port, and everything to actually start working with that instead of the MongoDB scale set. The advantage here is you don't have to manage your scale sets. Cosmos DB is scalable. You can replicate the data globally, which is kind of nice. As you can see here, here's all the locations you can add. Let's say I want to add East Asia. I literally just click here and I add East Asia to my MongoDB replicate set. It's kind of nice. Obviously, with a VM scale set, there's a little more work to be done there. I also have to put your apps on there, drop the, anything that you've got, figure out sharding, things like that. In this case, I just click on East Asia or West Europe and hit save, and it's actually going to set up replicas and start replicating to those regions for me. So that's scalable. The other thing I want to show you was, let's say the other option I have in the application properties there is MySQL. So if I say new MySQL, so we actually have MySQL service now. Azure Database for MySQL is in preview. And so in order to set that up, of course, if we go back to application properties, you can set that up here. And as I mentioned, Spring Music's cool because you can choose the data source you can use at runtime. So you can actually just change the parameter that you use at runtime to MySQL instead of MongoDB, and it's going to pick up the values here. Now what you would do is you'd actually get those values from MongoDB source. And once again, this is scalable. And where is my MongoDB or my MySQL database? There it is. MySQL sample database. It's scalable. There's all kinds of information that you can get from here. And once again, we have the geo-replication. So this is the kind of thing that's nice. You can also start scaling. This is taking a little while. Anyway, you saw the scaling. There it is. So these are all the regions that we have. MySQL right now, it's running in, I believe it's West Central US. If I want to click there, it's going to add it to another location. Oh, yeah, it's going to create a secondary geolocation, in this case Central India. Let's just skip that. And then I can scale up through here. So let's say I'm just not able to handle the application right now. I can increase the DTUs if you guys want to know what DTUs are. They're basically database transaction units that we use. It's a term that we're using for Azure. And I can increase this, well, in this case storage is maxed out, but I can go to the next version, premium, and then add more storage if I need to fire that up. And these, as you can see, the DTUs are much bigger when you get into the larger setup. And premium, well, I guess we're maxed out at 1 terabyte. It's a preview right now, so 1 terabyte of storage, and multiple DTUs can be configured from here. So I'm not going to save that for now, but that gives you an idea of some of the things you can do. You can also use, on the back end, there's storage, there's premium storage, there's all kinds of virtual networks, load balancers, DNS that you can use, something called Express Route, which is direct communication from your on-prem systems to local. And yeah, here's a little bit about the Azure Storage architecture as well. So pretty much every service you have, including MySQL and MongoDB, will have storage on the back end. You can import, export. You can basically scale your storage and geo-replicate it as well. And that's important when you're building these applications that need access to storage, access to file system. As I saw before, each CPU has its own onboard application storage, but also you might need a large amount of file system if you're handling pictures or cognitive services or things like that. And we actually have multiple client libraries that you can use to access your application, in this case Java endpoints, and you can use that through blobs to store media, tables, which is sort of like a NoSQL database, but not quite. It's just a non-schema table storage. And then you've got queues and file shares. And underneath that, you can scale out the infrastructure that you're going to use with each one of those, and to your application, it'll look like the same thing. It's just scaled out on the back end. So there you have it. I think that's what I wanted to cover today. We have some resources for you. One thing I wanted to show you, actually, let's see here. So we have the Java Developer Center, which helps you get going. This is just a high-level overview of what you can do with Azure. And then if you want to know how to do it with Azure, we have our Azure for Java Developers page. It's got a bunch of 5-minute quick starts to create a Java serverless function, Azure database, et cetera, et cetera. We work with Jenkins heavily as well. The thing I wanted to show you here is the Azure documentation. We have not just Java, but we have application SDKs for .NET, Python, Java, PHP, Node, and several other platforms here. We also have the Azure command line interface that you can use from your local machine. We have now, in case you didn't know, Windows actually supports Linux through what we call the Windows subsystem for Linux, or Bash and Windows. And we have an architecture page here, which is actually pretty cool. So there's Azure Application Architecture Guide, there's reference architectures, and there's actually cloud design platforms or patterns as well. So for Linux VM workloads, let's have a look at those. So if you want a single VM, load balance VMs, and by the way, this load balance VM workload is basically what Bidami used to create their image. So you've got the load balancer, you've got a scale set, which is managing everything inside an availability set, which is so as I mentioned, so scale sets are actually the VMs, availability sets are the region. We got the VMs and the storage accounts, and then the VHDs in there, which is the actual image with MongoDB running on it. And then we've got diagnostics and etc. So it's kind of cool. We've got some architectures there that are recommended for you, and some different pieces that you can use to review what you want to build. But I would suggest using, to get started with this and playing around with it, I would suggest doing what I did, which is take advantage of some of these multi-tier images that we've built in conjunction with Bitnami to deliver these out to the cloud. And So that's it. Any announcements we have coming up are through our blog, and we have a Java team that you can send email to directly if you have any feedback. If you're working with our SDKs or anything else to do with Java on Azure, just send a note to java@microsoft.com, and we can take some questions.
Yeah, Brian, let me check and see if there are any questions. Give me 1 sec.
Sure.
Yeah, there's one here. What about application performance monitoring?
Oh, okay. Yeah, we do. We actually have 3 different ways to do application performance monitoring. Let me see here. All right. Okay. All right. We actually have application insights, which is a quick way to do things. Basically, the way this works for Java is you get an instrumentation key. And by the way, this is a free service at a certain level if you have an Azure account already. I believe up to 5 users, and there is some level of activity that is managed as well. Actually, here, pricing details. So base monthly price is you get a gig per month of data. Additional data is $230. So that's one thing you can do. There are others as well. Let me just find that. So sorry, let me get back to this. So Azure Application Insights, what it does, you set up an instrumentation key, and for Java, you actually drop that into your Tomcat Web Apps folder. And once you've done that, it automatically sets up application monitoring for you. You can configure it, but there's a default profile you can use. And it uses Power BI to actually give you a dashboard. And all this is free up to a certain level. And the dashboard will actually help you manage CPU performance, storage performance, network latency. If there's an availability set, it's going to manage the connections between those availability sets, not manage them, but report them, monitor them. And then we have Azure Performance Monitor. Azure Performance Monitor. Where is that? Oh, no, sorry. We do actually have. I thought this would be easier to find. So we do, yeah, Azure Network Watcher. So it's specifically for network performance, and then we have Azure Performance Manager. Just a second, let me just get that up there. Yeah, so web app performance can be managed through that as well. Oh, actually, that's one thing I didn't show you too. So there's application insights. There's a good video here on controlling that with application insights, but there's more. Sorry, I'm just, I didn't have this link prepared. But let me just describe it to you as well. The monitoring services, you can monitor with App Insights that manages your app, and then we have Azure Monitor, which actually, here we go. Azure Monitor basically manages and reports on all monitoring services, which is mostly based on your Azure network. Application Insights is going to be more focused on your application end-to-end from the back-end data source to the application running itself. And then we have log analytics, which is basically, if you collect and manage any log information, which you should, log analytics will give you some great stuff. And all of those use the Power BI dashboard to give you a single view of what your application is working on right now. and where the hotspots could be for improvement. Hopefully that answers that.
Yeah, Brian, actually, I got another question here. Is there a free tier like AWS on Azure to get my hands on?
There is actually, yeah, that's an easy question. So Azure, there is a free account, and we've actually recently started with a bunch of free products that you can use as well. So there's a $200 credit if you want to get started. And then there is a free account. We also allow you to have 750 hours of virtual machines for Windows and Linux, 128 gigs of managed disk. Anyway, if you just search on Azure Trial, you'll see all the things that you can get for free. And if it says this is 12 months over here for free, on the right here it says always free. So for example, this is a big one, 10 web, mobile, or API apps using the Azure App Service you can have for free. And for now, always free. And then there's Azure Active Directory is always free within certain limits. There's a lot of things that are always free now, even after your $200 credit has run out and after the 12 months is gone for these things that'll be free for now in perpetuity. I don't want to say forever, but that's the way it is for now. And actually, yeah, that brings up an important point. So I've mentioned a couple of times web apps, and I didn't show you web apps. So new, if you go into the portal, and then if I search Java. So there's a number of things that come up for Java. This is a web app. It's just a Java coffee shop web app. I've already got it running. I'll show you in a minute. But then we also have Azure Zulu on Ubuntu, a pre-configured VM that you can use, also Windows Server, Apache Tomcat 8. So this is the other web app that you can use, and this is basically what I was describing before for web apps. The web app itself is just a managed service that you do. If I hit create here, it's going to create a web app instance for me with Tomcat and a compatible version of Java running. But I already have one, so let me show you that. Let's see here. App services. This is my actual working. So that's why I have so much stuff and it's a mess. This is my actual working copy of my subscription. So Tomcat websites demo. Basically, this is the site that I have. If I click there, it's going to fire it up. It's been a while since I fired it up, so it might take a minute. But let me get back there. The thing I want to show you here is different things you can do. You can scale up with web apps. So it's dead simple. I mean, it's just going to deploy a Tomcat web server for you, and then you have access to the web apps folder to drop a WAR file in. But I can also scale this up to different tiers if I want. So if I run out of basically steam on the application, I can pick another server that's going to be better for my needs, and it will automatically upgrade and scale everything for you. And speaking of scaling, the other thing this does is just nice is, I'm showing you this, but this doesn't give you obviously the control that you have over a VM. That's the trade-off. But I can scale to a specific instance count, for example, and it'll scale up. So say I know that I have applications on Mondays that are, that I need more juice on Mondays. Basically, I just scale it up like that. So it's a dead simple way of managing this, and we manage the back end for you. We have a Linux version of this and a Windows version of this. Windows is Windows. The Linux version of this is Docker with Ubuntu Linux running in the background. And basically anything that you have that runs with Ubuntu Linux and maybe Docker will run just fine. So I just clicked on scaling here. So let's say I want to have, my average CPU percentage is greater than 80 for more than 10 minutes. Then it's actually going to scale up the instance count by 1. And then if my CPU on that scaled up instance count is less than 60, it's going to decrease the count by 1. And I can actually set that up. I can say a minimum, maximum, and default, so I can change the default to 10 if I want, and it'll actually increase all of these by 10 when I do that. I think this one, because it's already created, I have to do it manually. But yeah, so it'll actually allow you to create that. Yeah, so I'd have to create this by 10. And there's a cooldown minutes, which is basically the cooldown means that it's going to sit there just in case it's needed again for 60 minutes, and then it'll fire it up again if it's needed. So that's a dead easy way to scale things as well on web apps. Obviously, not as much control as you have over VMs and Azure Container Services and things like that, but that is how it's covered.
Great.
So I see
Thanks,
we
Brian.
have, yeah, no problem.
Yeah, there's actually, I think we still have time for one more question, and I think you kind of covered it also to a degree earlier. What are the options for orchestrating containers on Azure?
You're right. So let me show you that actually. So I did mention the Azure Container Services that we have. Azure. So Azure Container Service is basically the way that you would orchestrate things. You can use containers. You can orchestrate with DCOS, Docker Swarm, Kubernetes. You use the tooling you're already familiar with. And actually, this would be a great way to show you something else. So Azure Container Registry. So let me show you here. So Azure Container Registry. Azure Container Registry is a way to, it's a private hub, basically. For those of you who work with Docker, you're probably familiar with Docker Hub. This is a private registry that you use to store and manage all of the images that you want to have on your Azure Container Service. So Azure Container Service you would create using Kubernetes in general. I mean, you can use DCOS or Docker Swarm as well, but mainly it's Kubernetes that people are using these days. We also have this thing called Draft and Helm that we have as part of our acquisition of Deis, as people might remember. And basically, Draft and Helm are a way of managing multi-platform containers that you want to use. It actually figures out what the code is that you're trying to use. This is I'm talking about Draft now. It figures out what the code is that you're trying to use on your application, and actually deploys a container wrapped around that to your Azure Container Registry that can then be deployed through the Azure Container Service. So, but it's really easy to set up, and it's kind of nice that way. Let me show you another little thing you can do if we have time. Go back into the portal. Two things you can do actually. New Tomcat. And by the way, you don't have to do everything through the portal. Actually, new app service. They keep moving things around on me here. Let's see. Java Coffee Shop we don't want. Web and mobile, there we go. Web app on Linux. Where is it? Sorry, they moved things around on me again. Web app for containers. Okay, here we go. So web app for containers, they used to be called web app for Linux. So you set up a web app yourself. Here you can use whatever name you want, and then you can configure the containers. So that web app I just showed you, you can go out to the Docker Hub and you can get a Tomcat image. Okay, and what this is going to do is actually going to add it to your Azure Container Registry if you don't have one already, or you can grab one from your Azure Container Registry or any private registry that's available through a URL. And when you hit OK, it's actually going to go out to Docker Hub, and if I say create here, it's going to create a container for me using Tomcat. It's going to put it in an Azure Container Registry for me and build a web app on that. And then I can use that to orchestrate through Kubernetes, et cetera, et cetera. One other cool thing I want to show you, speaking of that, I'm in the portal, and I've been showing you all kinds of things in the portal just because it's a little more visual. But if you want to use the cloud shell, that's what I'm showing you here. So the Windows subsystem for Linux, or Bash on Windows, you can use from Azure. I mentioned that before. Here's AZ. Here's the Bash on Windows. You can install it. It's a separate install if you're using Windows. Of course, you're on Linux. You can use Yum to go and get the Azure CLI, but we have the Azure CLI, which has control over all the applications that I've showed you today, including virtual machines, scale sets, all kinds of things. The other cool thing is if you don't want to install that on your machine, or you don't want to do it from anywhere, there's actually a cloud shell here. So AZ, once again, this is a container. It actually fired up a container using Azure Container Instances that I mentioned before. And it has AZ built in, it has Cloud Foundry built in, and I think it has Docker too. Yeah, so it has Docker in here as well. So if you're used to running from scripts with Docker, you can actually run from here using this command line shell. It automatically logs you into your application, into your account for Azure, because it knows you're in the portal already. It takes your credentials and logs you in. So AZ account list. So it knows what I have in terms of so it knows what I have already in terms of subscriptions that I can use here. Whoops, using a Windows command in Linux. So this is a full version of Linux. This is Ubuntu Linux, and it also has a bunch of pre-built things. It even has tmux installed, so you can use this from here. Another thing that I'll finish with is there is an Azure app that you can get for iPhone and Android, and you can use the command line from there. It opens a portal instance just like this, and you can click on the little icon on your phone just like you can here, and you can actually run things from your phone. The only limitation I'll tell you with the shell and with the phone is you don't have access to the local file system, for example. A typical workload would be you go in, you log in into your actual whatever you're working on Azure, and then you want to move something from your local machine out to the cloud. It doesn't have it here, but you can put it in blob storage or somewhere else that's URL accessible, and you can get it from there as well. So this works from the phone. You can actually implement a scale set and a VM with 32 cores or something on the plane on your phone. It's kind of cool. It's amazing the world we live in. So I'll finish with that.
Yeah, right, Brian. We've gone a little bit over the full hour, so we should probably end it now. Thanks so much for a very insightful presentation, and
Thank you.
I hope to see everybody at a future Azure webinar. Thanks very much.
Yes, and I will, in the future, we'll do a container-based version of this. It's just there wasn't enough time to get everything in, so I decided to focus on VMs and web apps for now.
That's great. Okay.
Yep.
Well, thanks.
Thank you.
Thanks very much again. Bye.
Thanks.